Hello mind risers, today we are going to work out the numericals from the calorimetry chapters. Before we start, let us learn certain formulas what are required for this chapter. The first formula that we will be using is Q is equal to mc delta T, where Q stands for heat energy, M is mass, C is the specific heat capacity, and your delta T is change in temperature. Next formula that we'll be using is H is equal to mc, where H stands for heat capacity. Then we have heat energy is equal to power into time. Okay, so this is power and this is time. And lastly we have Q is equal to ml, where L is the latent heat. Alright, so let us solve the numericals now. See, now starting off with the numericals, let us read this question. Calculate the amount of heat energy required to raise the temperature of 100 gram of copper from 20 degrees to 70 degrees Celsius. Specific heat capacity of copper is given to us. So always write down the given data. Mass is 100 grams. It is required to raise from 20 to 70 degrees Celsius. So the delta T is 70 minus 20, which is 50 degrees Celsius. And then we have the specific heat capacity of copper. So the value of C is 390 joule per kg per Kelvin. Now this is given in kg, so I'll convert the mass also to kg. So it's a direct sum where Q is equal to mc delta T 100 by 1000, because we are converting it to kg, into 390 into 50. So on cancellation, 45, 5 3s are 15. 1950 joules is the answer. Okay, now come to the next question. Find time taken by a 500 watt heater to raise the temperature of 50 kg of material whose specific heat capacity is given and the temperature from 18 to 38 degrees Celsius. So we need to find time is the question mark. Power is given as 500 watts. Mass is 50 kg. Then specific heat capacity C is given as 960 joule per kg per Kelvin. So I don't have to change the mass from to kg. It's already in kg. It's in the standard units. Then delta T is given as 38 minus 18, which is 20 degree Celsius. Alright, so we know Q is equal to power into time. So time will be Q by P, where Q is mc delta T by P. Substitute the values. 50 into 960 into 20 by power is 500. So we have 2 zeros are 0, 2 6 are 12, 2 9 are 18, 1920 seconds we have got in. So if to convert it to minutes, divided by 60, 63 is 180, bring down the 0, 2s are. So this answer in minutes, it is 32 minutes. Always preferred that the answer has to be written in minutes. The seconds will also fetch you marks. Next question says 45 gram of water at 50 degrees Celsius in a beaker is cooled when 50 gram of copper at 18 degrees Celsius is added to it. Now this is a mixture sum. Always divide the page into two parts. So we have water and we have copper. So mass of water is 45 grams. Initially at 50, it is cooled when 50 gram of copper. So mass of copper is 50 gram, which is initially at 18. The contents are stirred till a final temperature is reached. So the delta T for water is going to be 50 minus T, because this is cooling down, and delta T here it will be 8T minus 18 because the temperature is going to rise up for copper. Given C of copper is 0.39 joule per kg per Kelvin, and C of water is given as 4.2 joule per gram per Kelvin. So I guess there's an error here. This is actually joule per gram itself. Now whenever you have a mixture sum, you have to use the principle of calorimetry, which states that heat lost by a hot body is equal to heat gained by the cold body. So we have mc delta T is equal to mc delta T. Alright, so substituting the values, 45 into 4.2 in brackets 50 minus T. Here it's 50 into 0.39 in brackets T minus 18. Okay, so you quickly multiply these values, or you can also do sidewards cancellations, which makes it more easier. So I can cancel this 5 tens are 5, 9s are here, and then 4.2 and 0.39 will also go in 3's table. So 3 1s are 3 4s are 12, 0.13. Alright, so then let us just multiply these numbers. 9 4s are is what, 36, 9 1s are 9, 10 11. It's 12.6 into 50 minus T is equal to 1.3 into T minus 18. So immediately multiply them. So the 0 and the point will cancel. 5 6 is 30, 5 2s are 10, 5 6 minus 12.6 T is equal to 1.3 T minus 13 into 18. You need to multiply. 23.4. Okay, let us shift the T terms to one side and the numbers to another side. 12.6 T. So on adding this, I will get 653.4, which is equal to, this is 13.9 T. So 653.4 divided by 13.9 is the value of T. So on cancelling these two, we get 47 degree Celsius as the final temperature. Next question. Temperature of 600 gram of cold water rises by 15 degree when 300 gram of hot water is added to it. So we have hot water and we have cold water. Both are mixed together, so we have to use the principle of calorimetry. Temperature of 600 gram of cold water, so mass here is 600 gram. It rises by 15, so the delta T is given directly as 15 degrees Celsius. So the mass of hot water is 300 grams. At 50 degrees Celsius is added to it, so the initial temperature of hot water is 50. So the delta T is going to be 50 minus T for this. What was the initial temperature of cold water? So heat lost is equal to heat gained. Heat gained by the cold body. So mc delta T is equal to mc delta T. So the cc gets cancelled because it is both cases it is water. So the mass here is 300 into 50 minus T. Mass here is 600 into 15. So these 0 zeros I can cancel. 3 1s are 3, 2s are 2, 15s are 30. So the final temperature here is going to be 50 minus 30 degrees Celsius, which is 20 degree Celsius is the final temperature attained on mixing. But the question says what was the initial temperature of cold water. So since the rise in temperature for cold water was 15 degrees Celsius, so its initial temperature will be 20 minus 15, which is 5 degrees Celsius. Alright. Coming to the fifth question. It says 1 kg of water contained in a 1.25 kilowatt kettle. Calculate time taken for temperature of water to rise from 25 degrees Celsius to 100 degrees Celsius, and specific heat capacity of water is given to us. So mass is given in kg and I need to find time. So mass is 1 kg, which can be taken as 1000 grams. Power is given as 1.25 kilowatt. I'll convert this to watt by multiplying into 1000, so it is 1250 watts. Delta T here is 100 minus 25, which is 75 degrees Celsius, and C value is given to us. Time you need to find. So we know Q is equal to power into time, and time is Q by P. Q is MC delta T by P. Mass we have as 1000. C is given as 4.2. Delta T is 75 by 1250. So this 0 gets cancelled. The point and this 0 also I can remove. 5 2s are 5 25s are 25 1s are 25 3s are. So we have 3 2s are 6 into 42, 252 seconds. So 252 seconds, if you want to convert it to minutes, divided by 60, 64 is 240. So this is 4 minutes and 12 seconds. That's your answer. See the next question. It says a solid metal of mass 150 gram melts at its melting point of 800 degrees Celsius by providing heat at the rate of 100 watt. Time taken for it to completely melt at the same temperature is 4 minutes. What is the specific latent heat of fusion of the metal? So now we've got the latent heat sums. L we need to find. Mass is given as 150 gram. It melts at its melting point of 800 degrees Celsius by providing the heat at the rate of 100 watts. So power is 100 watt. Time taken is 4 minutes, which has to be converted to seconds. So multiplying by 60, 240 seconds is time. What is the specific latent heat of fusion? So L is what you need to calculate. So again power time is there, so we use Q is equal to power into time, and Q here is M L. Alright, so L you need to find. L is equal to power into time by M. Power we have as 800. Time here is 240. Mass is 150. 3 5s are 3 8s are 5 1s are 5. 5 2s are, because the 0 was gone, 2 8s are 16. Okay, so the 0 was still intact. So this is 160 joule per gram is what I have gotten, but since you have to write it in the standard units, so this would be 160, then other 1000 joule per kg, which if you have to write in the standard form, it would be 1.6 into 10 to the power of 5 joule per kg is the answer. Question number 7. A refrigerator converts 100 gram of water at 20 degrees Celsius to ice at minus 10 degrees Celsius in 73.5 minutes. Calculate the average rate of heat extraction in watt, and this is the given data to us. Let us draw a rough graph for this, a temperature time graph. So water converts 100 gram of water which is initially at 20 to ice which is at minus 10. So I need to mark 20 degrees. I'll have 0 and then I'll have minus 10. So from 20 to 0 it goes down. It freezes and then goes to minus 10 degree Celsius. So whenever we have a slant line, we use MC delta T, and we have a straight line, we should use ml. So here the delta T is going to be 20 in this case, and here the delta T is going to be 10 degree Celsius. So first find out the total heat energy, which will be MC delta T plus ml plus MC delta T. Since it's the same water which is becoming ice, the mass is common, so you can take out the m common. C delta T plus L plus C delta T of ice. The mass is given as 100 grams. C of water is given as 4.2. Delta T, we know here it is 20 degrees Celsius. L is given of ice, which is 336, plus C of ice is 2.1 into the delta T is 10. Quickly solve this. 0 point goes, so this is 84 plus 336 plus 21. Add all these numbers and multiply by 100. So on adding them, I get 441 with 20 joules as the heat energy. We need to find the average rate of heat extraction in watts. So we need to find power. Power is equal to Q by time. So Q is 44100. Time is given as 73.5 minutes. So we convert it to seconds by multiplying into 60. Cancel this out. So remove the point, add another 0. So we have 5. 1s are 5. 2 carry over, 5. 7. 5 8s are 40. 5 8s are 40. 2 and a 0. So I have 8820 divided by 147 into 6. So 6, let us try to cancel this out directly. 6 1s are 6 1s are 6, 6 4s are 24, 6 7s are 42, 0. So we have 1470 by 147, which is nothing but 10 watts is the answer. The next question here says the temperature of 170 gram of water at 50 degrees Celsius is lowered to 5 degree by adding certain amount of ice to it. So we need to find the mass of ice added to this water. So we have water and we have ice. So mass of water is given as 170 gram, which is at 50 and it is lowered to 5. So the delta T is going to be 50 minus 5, that is 45 degrees Celsius. Adding certain amount of ice, what we don't know. C of water and L of ice is given to us. Alright, so here heat lost by the water, which is the hot object, is equal to heat gained by ice in this case. So this is MC delta T, which is equal to, now the ice needs to melt first and then has to raise the temperature by 5 degrees Celsius. So we use MC delta T plus ml for ice. So the mass of water is 170 gram. I am taking the value of C as 4.2 in joule per gram. They have given in joule per kg just to make the calculation easier. M can be taken out common here. Since ice becomes water, so the C value will remain same. Delta T is going to be 5 minus 0, which is 5, plus L is also given to us 336. Alright. You can keep these values as it is and then just solve this and divide it there. So on adding these two, we get 357. So mass I'll keep here, now the same values. by 357. So this goes in sevens table. I'll remove this point and add another 0. 7 6 are 42, 7 5 are 35, 7 1s are, and then we have a 0 here. This 0 gets cancelled. 17 1s are, 17 3s are is 51, 3 1s are 3, 2s are 2, 45s are is 90. So mass is 90 grams. Moving on to the next question. Calculate mass of ice needed to cool 150 gram of water contained in a calorimeter of mass given such that the final temperature is 5 degrees Celsius. So we have three objects here. We have water, we have the calorimeter, and we have ice. Okay, always remember, since the water is contained in the calorimeter, so the delta T is going to be same for both of them. The mass of ice needed is what you need to find to cool 150 gram of water. So mass is 150 grams. Calorimeter mass is given as 50 grams at 32 such that final temperature is 5. So the delta T is going to be 32 minus 5, which is 27. So it's going to be the same even for the calorimeter because the water is inside the calorimeter. And here delta T of ice will be 0 to 5, which is 5 degrees Celsius. The rest of the data is mentioned there. So these two are the hot objects and this is the cold object. So heat lost is equal to heat gained by ice. So heat lost is by both water and calorimeter. So MC delta T of water plus MC delta T of the calorimeter is equal to MC delta T plus ml of ice. Fine. Now let us substitute the values. 150 into C of water is given as 4.2, delta T is 27, plus this is 50 into C of calorimeter is also given to us, delta T is 27. Your mass can be taken out common, 4.2 into 5 plus 330. Alright, so let us multiply and solve these values. So the point and the decimal it's cancelled here, and I need to multiply all of this here also. Point and the decimal I can cut out. So let us solve quickly. This is going to be 21 plus 330, which is going to be 351 m on the right hand side. Here 4 5 is 20. This is going to be 540 plus this we need to calculate quickly. Well, on calculating this we get 17010. Add these two. So the mass of ice is going to be 17550 by 351. This goes directly 5 times. So 50 gram is the mass of ice needed. Next question says calculate total amount of heat energy required to convert 100 gram of ice, which is initially at -10, completely into water at 100 degrees Celsius. So quickly draw a graph again. So I have -10 degrees, I have 0, and then it goes up to 100. So from -10 to 0 there's going to be rise in temperature where it will come and melt, and again there's going to be a certain rise in temperature. So here we use MC delta T, here we use ml, and here again MC delta T. Alright, so we need to find the total heat energy, which is equal to MC delta T plus ml plus MC delta T. This is for ice and this is for water. The mass, since it's the same mass of ice which is becoming water, you can take out the m common. C delta T plus L plus C delta T. Let us substitute the values. So mass is given as 100 grams. C of ice is mentioned as 2.1. Delta T here initially it's going to be 10 degrees Celsius. L is given as 336. C of water is 4.2 and the delta T is going to be 100 there. We just have to add all these values. 1 plus 1, 7, 2, 5, 6, 7, another 777, 100. But here since nothing, so it's all correct. So this is 77,700 joules, which can be written in a standard form as 7.77 into 10 to the power of 4 joules is your heat energy. Next question, 200 gram of ice at 0 degrees Celsius converts into water at 0 in 1 minute. When the heat is supplied to it at a constant rate, in how much time 200 gram of water at 0 will change